Okay, in this video we're going to talk about graphing tangent and cotangent, and we base it on our understanding of sine and cosine. So I've drawn up here the graphs of sine and cosine, just so you remember, although you should be working at getting them, being able to generate them pretty quickly on your own. And let's also keep in mind that tangent is sine over cosine. We learned that in an earlier video. And cotangent is, let's erase that. Cotangent is cosine over sine. So since we know really well where sine and cosine are 0 and 1, we're going to take a look at what that means in terms of tangent. So tangent, when cosine is 0, notice we're going to have a 0 on the bottom, which will make tangent undefined. And when sine is 0, then we have a 0 on top, and tangent is equal to 0. So that means every place that cosine is 0, which would be there and there, we're going to have undefined. And every place that sine is 0, tangent is going to be equal to 0. Okay? So let's go ahead and draw a picture of that. So if I'm trying to draw a graph of, oops, that was kind of wobbly. Really wobbly today for some reason. Okay, here we go. That's as good as it's going to get. Here's that. Okay, so let's mark our normal. There's pi over 2, pi, 3 pi over 2, and 2 pi. So that's pi, that's 2 pi. Okay, so every place where you see the purple highlight above, tangent's going to be 0. So we'll put a 0 right there, a 0 right there, and a 0 right there. And everywhere you see this highlighted green up above in cosine, we know that tangent is undefined. Now when a function is undefined, that means there's a hole or an asymptote usually. In this case, it's an asymptote. So I'm going to draw these asymptotic lines in here. And notice when we take sine a little bit further, it's also, cosine a little bit further, it also hits 0 out here at negative pi over 2. So we can throw an asymptote in there also. And if we kept the pattern going, there's going to be another asymptote out here at 5 pi over 2, etc. So we have a whole bunch of asymptotes for tangent. So now what happens in between the asymptotes? Well, we know it's 0 halfway in between. And if you look at sine in the first quadrant, it's headed towards 1, so it's getting bigger and bigger. Cosine's headed towards 0, so it's getting smaller and smaller. So we have a fraction that's getting bigger on top and infinitely small on the bottom, which means overall the fraction itself is going to blow up. It's going to get bigger and bigger and bigger. So what happens is you get something going like this. And if you notice on the other end, over in the second quadrant, now sine is getting smaller and smaller and smaller, and cosine's getting headed towards 1. So we have a cosine that is basically headed towards 0, but the other way, back this way, it's going to be blowing up negative because sine is positive and cosine is negative. So we have something like this. And then once you get back to here, both sine and cosine are negative. So that means you're going to have a positive overall. So it's heading up like that. And now that we've drawn this, we've seen the pattern. So basically we have a bunch of squigglies here. They kind of look like y equals x cubed, but they're not because of the asymptotes keep them confined in a certain space. So that's tangent. Cotangent will follow a similar method for coming up with this. Let me mark my pi over 2, my pi, my 3 pi over 2, and my 2 pi. There's 2 pi. There's pi. And so the same idea, wherever sine is 0, now cotangent is undefined. So if you look at the purple spots, that's where we have the asymptotes for cotangent. So I have an asymptote on the y-axis, one at pi, and one at 2 pi. And also when cosine is 0, where the green spots are, cotangent is 0. So we have a dot there and a dot there. And it's going to look like tangent, except for the difference is, notice in the first quadrant, which would be right in here, both sine and cosine are positive. So that means that the tangent, or the cotangent curve, is going to come down like this, and then head down towards infinity like that. So it kind of squiggles the opposite way. Okay, so that's tangent and cotangent for you.